All right, let's talk about one of Python's most powerful and maybe a little misunderstood typing tools, TypedDict. If you've ever found yourself wrestling with dictionaries, just wishing you had more type safety without having to slow your code down, well, you're in the right place. Let's dive in. You know the feeling, right? We've all been there. You're pulling in some JSON from an API, passing a dictionary around between a few functions, and then bam, a key error just blows up your program. Or even worse, you get a silent failure because a value was a string when you were absolutely sure it was going to be an integer. It's a nightmare. And this is so often the culprit. You see dict, string, any, and you think, great, I'm using type hints. But what you're really doing is telling your type checker, hey, just give up. Don't even bother looking here. It gives you zero guarantees about what keys are in there or what types their values are. It's a code smell that completely silences the very tools that are supposed to catch your mistakes. So here's how we're going to tackle this. We'll start by introducing typed.Dict as the solution, this sort of static blueprint. Then we'll get our hands dirty defining schemas. After that, we'll cover the really important rules of how they play together. And we'll wrap it all up by figuring out when to use typeddict versus the other tools in your belt. So what's the fix for this whole dictionary mess? Well, we need a static blueprint. And that blueprint, you guessed it, is typeddict. You can think of it as the perfect tool for bringing some much-needed order to that chaos, letting you lay down a precise contract for what a dictionary is supposed to look like. Now, the phrase to burn into your memory here is static-only blueprint. This is the absolute core idea. A typeddict isn't some new kind of object that your code is interacting with when it runs. Nope, it's just a set of instructions for your static analysis tools, like MyPy, so they can enforce a structure before your code even gets a chance to run. And the payoff for this static-only approach? Oh, it's a big one. Its biggest advantage, really? Zero runtime overhead. And I mean zero, none. Zilch, because it's just a hint for your linter, all that type information gets erased when the code actually runs. You're left with a plain old, super fast Python dictionary. You get all of the safety with absolutely no performance penalty. And that's really the key takeaway right there. When you make a typeddict, what you're actually getting at runtime is just a regular dict. The Python interpreter itself, it has no idea your schema even exists. The type checker did its job during development, and now it's out of the way. Okay, so how do we actually go about defining these schemas? Well, the story here has gotten a lot better over the years. typeddict has really evolved from being kind of a blunt instrument into a precision tool that gives you really fine-grained control. So back in 2018, it started with a simple total parameter. It was all or nothing. Either all the keys were required or all of them were optional. But the real game changer came in 2021 with PEP 655. That gave us required and not required, which let you specify this stuff on a key-by-key basis. And that is so much more realistic for modeling real-world data from APIs. All right, you've defined your schemas. Now, how do they interact with each other? It all comes down to what we call structural subtyping. And honestly, you can just think of it as duck typing, but for your data's shape. So what this means is that it doesn't matter what you call your typeddict, or if it inherits from another one. The only thing the type checker cares about is its structure. If one dictionary has the shape, the right keys, and the right value types that another one expects, boom, they're compatible. It's all about what it has, not what it's named. This leads us to our first big rule. It is totally fine for a dictionary to have more data than what's expected. So, for example, a movie with director has everything a movie needs, plus an extra key. And that's perfectly safe. A function that just wants a movie will just ignore the extra director field. The wider type fits where the narrower one is expected. No problem. But, and this is a big but, it gets very strict right here. You cannot use a dictionary that has a required key where an optional key is expected. And you might be asking, why? Well, think about it. The code that's expecting an optional key might try to delete that key. And if it did, it would break the promise, the contract of the original type, which guaranteed that key would always exist. This rule is all about preventing unsafe operations. And this is another one of those gotchas that's super important. You can't just pass a typed dict to a function that wants a generic dict. Why not? Because a generic dict implies you can do anything to it. Add keys, delete keys, go crazy. That would break your schema's contract. The safe way to do it is to type hint with mapping. Mapping signals a read-only view which totally respects and preserves that structural guarantee. So now for the million-dollar question. We've got things like data classes and Pydantic out there, so when exactly should you reach for TypedDict? It really comes down to picking the right tool for the job. This table, honestly, it makes the whole trade-off crystal clear. Just look at that runtime validation row. TypedDict and data class, they do none of that. Their job is done before your code ever runs. Pydantic, on the other hand, is all about runtime validation. That means it's actively checking and parsing the data as it comes in, which naturally adds a little bit of performance cost. So, here's your checklist for when TypedDict is a perfect choice. 1. You're dealing with a trusted data source, like passing data between your own internal functions. 2. Performance is absolutely critical, and you can't afford any overhead. And 3. It's amazing for interoperability, like when you're trying to add type safety to an old legacy codebase that's just full of dictionaries. Now, on the flip side, when should you grab something else? Well, if you're getting data from anywhere outside your system, an API, a file, user input, you absolutely want Pydantic. It is your safety net. It provides runtime guarantees. And if your data needs to do things, if you need methods on your data objects, then a data class or just a plain old class is what you're really looking for. If you remember one thing, let it be this. TypedDict is for static safety. It's like a pre-flight check on your code's logic before you take off. Pydantic is for runtime safety. It's the active monitoring system that checks the data itself while you're in the air. They solve two different problems at two completely different times. So the question you should always be asking yourself is this. My data is getting checked, sure, but is it being checked at the right time? Because it's not enough just to have checks. You need the right kind of check at the right stage of the process. And making that choice, that's the key to writing truly robust and reliable Python code. Thanks for tuning in.